In the previous video, we learned how to prove that a quadrilateral is a parallelogram. This is useful because once we know that a quadrilateral is a parallelogram, we can apply all of the properties that we know to be true about a parallelogram to our particular quadrilateral. So summarized in the box there are all the properties that you know are true about a parallelogram, and we're going to go ahead and use those in conjunction with what you learned in the last video to move on and write some more proofs. In example 1, it tells us that JKLM is a parallelogram. I really don't have a way to mark my diagram to indicate that something is a parallelogram, but I really do want to have a way to do that because it's useful information to me. So this is just something that I do. Anytime I have a figure that I know is a parallelogram, I'll take my highlighter and I'll highlight its sides. And that's an indication to me that I now know that that particular figure is indeed a parallelogram. We're also given that segment JO is congruent to segment OL. So I'm going to go ahead and mark those as such in the picture. And we're trying to prove that segment OP, so this little piece right here, is congruent to segment OQ. I can't help but notice that segment OP and segment OQ are sides of those blue triangles. So now I'm thinking to myself, if I could only prove that those two blue triangles are congruent, then I could use CP/CTC in order to get their corresponding sides congruent. So I'm going to ask myself, is it possible to go ahead and prove those two blue triangles are congruent? I've already got one pair of sides that I have from the given. I have a pair of congruent angles there at point O, and they're congruent because they're vertical angles. And because my yellow figure is a parallelogram, I know that the top and the bottom sides are going to be parallel. And if the top and the bottom sides are parallel, that's going to make angles 1 and 2 congruent, because anytime lines are parallel, alternate interior angles are congruent. So looking at those blue triangles now, I can make those two congruent by angle side angle. And once they're congruent, it follows that all their corresponding parts have to be congruent, namely the corresponding parts that I'm looking for here in this proof, side OP and side OQ. So that's the gist of how I'm going to go about writing this proof. I think I'll go ahead and do this in statement reason form, just for all you two-column lovers out there. If you'd prefer to write your own as a flow proof, definitely feel free to write your own proof as a flow proof. The order that you want to put the congruent parts of your triangle in here doesn't really make a difference. I'm going to go ahead and start with that first given, that figure JKLM is a parallelogram. And because he's a parallelogram, I automatically know that the top side and the bottom side are parallel. I also know a whole lot of other things about him, but the only pieces I really need to pull out of that are the parallel lines, because then I'm going to use those parallel lines to make angles 1 and 2 congruent. So the top side, JK, is parallel to the bottom side, ML, and that's because a parallelogram has opposite sides that are congruent. Sorry, opposite sides that are parallel. And I'm going to cite statement 1 because statement 1 is where I had the parallelogram. And now, because those lines are parallel, now I'm all set up to go ahead and draw the conclusion that angles 1 and 2 are congruent. And this was because anytime I have parallel lines, it makes the alternate interior angles congruent. And I'll go ahead and cite statement 2 because statement 2 was where I had my parallel lines. I know that angles 5 and 6, which I'm going to label the vertical angles in my diagram, are congruent. And that's because vertical angles are always going to be congruent to each other. And I know that side JO is congruent to side OL, because that was given to me also. So at this point, I've talked about two pairs of congruent angles. I've discussed a pair of congruent sides. Now I'm all set to go ahead and draw the conclusion that those triangles are congruent. And when I name the triangles, I'm going to be very careful to align or match up their corresponding parts. So in the top triangle, angle J will correspond to angle L. In the bottom triangle, O will correspond to itself because of those congruent angles at vertex O. And angle P in the top triangle will correspond to angle Q in the second triangle. And those were congruent by looking at my picture, angle, side angle. And I'm going to cite statements 3, 4, and 5 because those were the statements where I discussed my congruent angles and my congruent sides. And now lastly, once I've shown those two triangles to be congruent, I now know that all their corresponding parts are congruent. And side OP in the first triangle corresponds to side OQ in the second triangle. And again, I can write the whole statement. I can say when two triangles are congruent, all their corresponding sides or all their corresponding angles must be congruent, but I'm just going to use CPCTC. Corresponding parts of congruent triangles are themselves congruent. And then I'll cite statement 6 because that's where I discussed or talked about my congruent triangles. All right, so number 1 is a wrap. Let's go ahead and we'll talk parallelograms in number 2. In number 2, we're given that ABCD is a parallelogram. So once again, I'm going to grab my highlighter and I'm going to go highlight figure ABCD because now that's a mental clue to myself that that figure is indeed a parallelogram. We're also told that segment AD is congruent to segment DE. So those two pieces are congruent. They want us to show that the quadrilateral at the bottom of that picture, which I'm going to go ahead and highlight maybe in a pink dot, they want us to show that that guy is a parallelogram. Well, I'm going to say that my yellow figure is a parallelogram because it was given to me to be a parallelogram. So that makes side AD automatically congruent to side BC because in a parallelogram, opposite sides are always congruent. I also know that the left side of that figure and the right side of the figure are parallel because in every parallelogram, opposite sides are parallel. So now if I look at my pink figure, I've got the left side and the right side congruent. I've got the left side and the right side parallel. So I've got me a figure with the same set of sides, both parallel and congruent. That makes my pink dotted guy a parallelogram. And that's where I'm trying to go with this proof. So for all you flow proof people, this one is for you. I'm going to go ahead and start with figure ABCD being a parallelogram. I know that's a true statement because it's given to me to be a true statement. And because that's a true statement, I know that the left side and the right side are parallel. I'm going to be a little sneaky about how I write this. Instead of writing line segment AD, I'm going to write line segment or line AE. There are two different ways to name the exact same geometric figure. But one of those ways is going to include my pink dotted quadrilateral at the bottom of the figure, where the other way doesn't. And I do want to include that because I want to use that in the next step in my proof. And I know this is a true statement because parallelograms have opposite sides that are parallel. Because this guy's a parallelogram, I also know that the left side and the right side are congruent. And that's because parallelograms have opposite sides that are congruent. I want to get to side DE being congruent to side BC. And right now, all I know is that segment AD and segment DE are congruent. And I'm going to work a little bit of math magic here. If I know that side AD is congruent to both BC and DE, then I know that BC and DE have to be congruent to each other as well. And you can write a reason, talk about two segments being congruent to the same segment must also be congruent to each other. I'm just going to go ahead and use substitution. I'm going to take out segment AD and I'm going to replace it with its equivalent. So I'm going to call that substitution. So now, in the purple bubble, we have left side and right side parallel. In the green bubble, we've got left side and right side congruent. So we've got the same set of sides, parallel and congruent. That makes our figure a parallelogram. And I'm just going to say a quadrilateral with the same set of sides. Both parallel and congruent. Has to be a parallelogram. All right, so like always, when we talk proofs, we've bitten off quite a lot. But I do want you to go ahead and take some time and summarize the key ideas and the important understandings that I wanted you to get out of watching this video, and then see if you can take and apply what you know in order to write the second proof on that page.